The last method that we need to review together for solving quadratic equations is everybody's favorite method, the quadratic formula. And this is because the quadratic formula works every time, all the time. So even when we have quadratic functions that cannot be factored, we're able to apply the quadratic formula to solve for the variable. So to get us started, let's suppose that we're given the quadratic equation ax squared plus bx plus c is equal to 0. And of course, our leading coefficient a cannot be 0. Then the quadratic formula allows us to solve for x as follows. So the quadratic formula tells us that x is equal to the ratio minus b plus or minus the square root of b squared minus 4ac, and that's all divided by 2a. Now, where exactly does this quadratic formula come from? So in order to obtain this solution for x, we need to go ahead and complete the square on this quadratic equation. So recall from the completing the square method that in order to complete the square on such a quadratic equation, the first thing that we need to do is isolate the constant term c to one side, and then if that leading coefficient a does not equal 1, then we're going to need to simplify by dividing both sides of the equation by a. So notice here that we've isolated our constant c, and then since a is an arbitrary constant, we can't assume that it's equal to 1. So we factor that constant a out of both terms, and now we can divide both sides by a. So now that we have obtained an easier form of our quadratic, we're ready now to complete the square. And recall, to complete the square, we're going to need to take half of the coefficient attached to the variable of degree 1 and square that, and then add this to both sides of the equation. So after we add this, the half of the coefficient of the variable of degree 1 squared to both sides of the equation, we have obtained that perfect square trinomial, which we then factor to the square of the binomial. And notice here, I've just switched the terms of the constants on the right-hand side so that the positive term comes first. And now that we've officially completed the square, before we start solving for x, let's actually take this one step further and simplify the terms on the right-hand side by finding a common denominator. So now that we have simplified our constant terms, we're officially ready to start solving for x by applying the square root method. So taking the square root of both sides of the equation, notice on the left-hand side how the square and the square root will cancel each other out, leaving us with x is equal to x plus b over 2a is equal to plus or minus. Now notice here, under the square root on the right, we have the ratio of two terms, or the division of these two terms, so we can split that radical up and say that this is equal to plus or minus the square root of b squared minus 4 times a times c, and that's all divided by the square root of 4a squared. And we're excited here because we realize that this denominator is a perfect square. So we can take this one step further in simplification and say that this is going to be equal to, so we have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac, and that's all divided by 2a. And we're so close now. The last thing that we need to do here is isolate x by subtracting the ratio b by 2a from both sides. So we have that x is equal to minus b by 2a plus or minus the square root of b squared minus 4ac, and that's all divided by 2a. And lucky us, we have the same denominator, a common denominator, which allows us to rewrite this expression as negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, which is the quadratic formula. So this matches the function or the expression that we defined up at the beginning.